discussing about the core Kubernetes concept. Today we'll see how to create or deploy the pods, and we'll see how to access a pod through your kubectl command as well as through your NodePort service. So now we'll see how to create some pod. Pod is just any task that you run on your Kubernetes cluster. As part of the pod deployment, we'll be working on some replications. So I'll show you how to deploy a pod now. Before we actually work on pod, yesterday itself I showed you how to create the manifest file in the form of YAML. There are four important keys in manifest file, that is your API version, kind, metadata, and then the specification. Spec is used to identify the container specification or the template that you want to replicate. I'll give you one quick example now. Before that, let's check if our cluster is up and running. Yes, we have 3 nodes available and it's all up and running now. And if I say kubectl get pods from all namespaces, you should able to see all the Kubernetes core components are up and running. It means our Kubernetes environment cluster is available for our deployment. All that you should do here is we have to create one manifest file, and through that manifest file we'll see how to deploy our pods. So I'll give you one example here. Just observe this. So consider this manifest file here. I'm going to create a file called nginx-pod. It is the name of the file and I want to save it as YAML file, and we are going to create a Kubernetes object called pod, and the API version for pod is v1, and the metadata that is going to identify the name of the pod. Nginx-pod is the name of the pod which you want to create, and you can able to assign some labels. Labels are used to assign some additional filters or tags to your Kubernetes object. It can be based upon the environment name or it can be based upon the development team, whatever it is, right? So it is just an alternate tag we can able to assign to the pod, and then we are going to give a container specification. Here in container specification, we're going to give a name of the container and the image which you're going to execute. So Nginx is one of the images, okay? Like it's like your Tomcat application service. Nginx is also another web application service. It will get executed within your node and it runs in port 80. That is the default port for Nginx. So it is also used to run some web application tasks like Tomcat web application server. Once you identify the name of the image, you can able to map or mount the port number. This is the container port that you can able to assign to this container. So my requirement is Nginx is one web application. I want to deploy this Nginx web application in the form of pods in my cluster. So once the manifest file is ready, we use the kubectl commands like kubectl create command to create the file. File in the sense, what all the objects we are going to maintain in the file, everything will be created. So in this particular file, we are going to give a definition for Nginx pod, right? So like this, we can able to create multiple services within a single file. It can be created by using kubectl create command. F denotes a file name. And once it is created, it is just a process of deploying it, okay? So it gets deployed. You can able to see the pods will be up and running. Once the pod is up and running, you can able to log into the pod or access the pod to capture the application details. So it is just a simple process of deploying your pod in your Kubernetes cluster. Let's create one folder first, okay? So that it will be easy for us to organize the content. So nginx-pod.yaml, it is a manifest file you're going to create now, and simply you can use this script. So this is just an example. Yesterday we discussed about the architecture and the pod and other pod networking and other stuff. So just wanted to show you how to deploy a simple pod in cluster, and we'll see how to log into the pod. This is what the point. We'll see how to log in using kubectl, and I'll show you how to access that application running inside the pod through your web browser. So prepare this manifest file and save this. Once the file is ready, all that you can do here is, if you can see a kubectl get pods, you won't find anything because we haven't created any pods here till now. So all that we're going to do here is we are going to create a new pod now, and for that we use a command kubectl create -f followed by the file name. nginx-pod.yaml. This is a file which we have in this directory. I want to use that file name to create the objects. Now if I say kubectl get pods, I should be able to see those details there. So it is in pending state. In few seconds, it will be up and running. So yesterday itself, I was talking about the pod's lifecycle. Remember? So pod's lifecycle means whenever you deploy your pod, it will be first received by your API server, which will validate your request. And once the request is valid, it just deploy, identify the healthy worker node, and it will get deployed to the healthy node. So till the time, the status of the pod will be in pending state. Once that deployment is completed successfully, it will be in running state. So let it be up and running. You can see now it goes to running state. Can you see this? While it was validating, it is in pending state, and now one instance of pod is up and running. I'll do one thing, restart my machines, okay? I'm going to restart these nodes now because I can see the response is very slow today. Sometimes during Sunday, it happens with the T2 micro instance types. It is getting into stop state, right? It's not, it's stopped completely. So this Kubernetes master is still getting into stop state. Let's wait for some time. Yes, now it's stopped. Okay, so let me start these nodes now. Let's connect to this machine first. So I'm taking the public IP of this node and connect to this one. Yeah, we have 3 nodes attached together, and now if you say kubectl get pods, you should be able to see one pod. It is up and running. We just created this pod using this manifest file, right? So the file name is nginxpod.yaml, and the pod Kubernetes object type is pod, API version is v1, metadata to identify the name of the pod on the label, specification to give the container name and the image. So this image is available in your container registry and uses the default port called 80. So this is how we prepare the manifest file, and using this kubectl create command, you can create this object. That's what we did now. And once a pod is created, if you want to get the list of pods, you can simply say kubectl get pods. And also we talked about the IP address, right? Whenever we deploy any pod, the pod will be allocated the unique IP address. So to capture those details, we can use -o wide option. So output wide. So if you simply say kubectl get pods, you can get the name of the pod, number of instances, and the status of the pod. That's it, whether it's up and running or not. But if you want to know the IP address of this pod, you can use -o wide. Some more information like IP address and in which worker node it is deployed. You can see it is deployed in worker node 1, right? And this is a unique IP assigned to this pod. So how this unique IP is assigned means it is based upon your configuration, yesterday's configuration. Like while initializing your pod, we use pod network CDR using 10.244.0.0. Based upon that data range, it creates pod IP address. It is no way related to your host machine's IP address range. Okay, so this is how we define the or create the pod. And also there is something called kubectl get pods. And if you want to get the complete information about the pod, like for example, the manifest file, whatever we prepared, it is just with the name of the pod, container, image, and the port number, etc. But how it gets stored internally, like yesterday we talked about etcd, right, which maintains the complete information about the Kubernetes objects and the cluster. So how this pod is defined and stored in etcd means you can able to extract it by using this YAML format. See, this is the complete manifest file of my pod. Actually, we just pass these parameters, but actually it is stored with all these required parameters, include the volume, IP address, service definitions, everything. So in this host machine, your pod is up and running now. And there is another command called kubectl describe command. So this kubectl describe command is used to describe the properties of any Kubernetes object. It is not just your pod. Any Kubernetes object description, if you want to capture, you can use kubectl describe command. So it is something considered as a diagnostic tool actually used to analyze the Kubernetes objects. If you want to analyze the pod, you can simply say kubectl describe followed by the pod name. Kubectl describe followed by pod name. So now if you can see here, it shows the name of the pod, in which namespace it is up and running, and in which node it is up and running, when it gets created, what are the labels we assigned, and what is that image, container name, and container ID that is generated. Container ID is responsible to create. And then we have an image. So using this image, we are creating this container, and it is deployed in the form of pods actually. So like this, there is another important thing called events. Event means it is used to define the properties of your object. Like for example, what are all the actions that you perform on the particular Kubernetes object, everything will be logged here. So tomorrow, if you want to diagnose the issue, sometimes what happens, in real-time environment, our pods will be up and running. If you execute the command kubectl get pods, you can see the pod execution status will be successful, but you might not get the response from the application running inside the pod. So if you want to diagnose that issue, you can just use the describe command and understand the events. Starting from the creation, what are all the actions performed on that particular object, everything will be captured and made in form of events. So this is just to diagnose the issues. If any issues occurs, it can be quickly diagnosed. So here you can see I was creating this pod and it was up and running. All of a sudden, what I did, I just restarted my node. So because of that, it is having this failure. And again, it has created a new container and it is successfully up and running now. So that is how your lifetime or the life cycle of your pod will be. And events are very much important to understand the actions that we perform against the pod. So these are the basic commands. So next we'll see how to log into the pod. Okay, during Kubernetes, it's a container modules, we talked about exec command. If I say kubectl get pods, I have just one pod up and running. And if I want to log into the pod, what I can do is I can simply say kubectl exec -it followed by the pod name. So name of the pod is nginx-pod. This is the name, right? So you can use this name here in bash mode. See here, now the control is inside the pod actually. So this is a node and this is a pod. And here I can able to explore the file system, or I can able to handle the changes, whatever I need. Everything is possible. That's like how you log into your container. You can log into your running pod using kubectl exec-it. Right. So now the point is, let's create one HTML file. Like since we are using Nginx, this is the default directory for Nginx basically. Even if you install Nginx on your virtual machine, you can find this directory there. And here you can see HTML. Within that, you can see index.html page. Index.html page. This is the default or home page for your Nginx. So like this, we can able to create our own application. Assume that I'm going to create one HTML file within that and exit from that pod. Okay. So all that I did here is I just hit into this directory and created test.html, and this is the content. If you want, you can able to verify that once. See here, test.html has been created by us now. So this is just a small web application, website or web page we deployed in this directory. Okay. So it means we have deployed one web application in Kubernetes cluster and it is running as a pod now. So whenever we deploy any web application, we should able to access through web browser, right? So how we can able to access the application running inside container through web browser? So using port mapping, we can able to map our host port to the container port. Similarly, here we use one service called NodePort Service. Whenever we create any pod, and if you want to expose the pod to internet, we can create a NodePort service to that pod. Once you create a NodePort service, you'll be getting one port number, unique port number assigned to that, like in the form of 30,000 to 32,767. This is a port range. Between this port, uniquely assign one port to your service, and that can be mapped with your pod. So how to create a NodePort service means it's very simple. Just run the command kubectl expose this pod using this NodePort service, and this is a container port which we have in our container port definition. So it means we are trying to map the container port with that node port. Node port is your worker node's port number where you deploy your pod. So let me run this command, and now you can see one new service is available. If I say kubectl get svc, you can able to see Nginx pod in the same name. It has created one service. It is of type node port, and when it is a node port type service, you should able to see a unique port number that ranges between 30,000 and 32,767. So what is the purpose of creating it means? We are trying to map our container port with this node port. In your open source, that is your containerized environment, we were able to map our host port with the container port, right? But here we cannot directly map our host port with the pod. It will be done through your node port actually. So once you have this available, all that you can do here is you can use the external IP address of the node where your pod is up and running now. So it means get pods -provide. So now you can see this pod, it is up and running in worker node 1. So what is IP address of worker node 1 here? This is the thing, right? So just take the IP address of this node and you can able to update that IP address. And in our case, the node port value is 31058. That's it. Simple. If you simply run this, also you can able to find the default directory. See, this is the default home page for Nginx. But in this, we have deployed one web application, right? That web application name is test.html resource. So you can able to specify the resource name here. Sorry. So this is a small web page which we created in this by editing the file. Right. So as part of this demo, we have created one pod. We have created one NodePort service associated to that pod. And here, all that you should understand here is how to prepare a manifest file to deploy a pod instance, and how to use your create command, describe command with all the flag values. And not only this, it is also recommended to understand the way of interacting with your pod. At any time, you should be able to log into your pod and understand what exactly happens in the particular application. Got it? And finally, if you want to access that pod to internet, you need to expose it to internet using your NodePort service by using command. It is just an ad hoc command actually. kubectl expose pod is an ad hoc command through which we can able to create a service. The service, it can be your cluster IP or load balancer as per your need. So once the process completes, if you want, you can delete all the resources. Like if I want to delete a service or a pod, simply say kubectl delete followed by the type of service and the name of the service. So honestly, don't keep your resource occupied with these services, just remove it. So we were just discussing about the pod deployment, right? So as we discussed yesterday, we were able to install and configure Kubernetes cluster. And these are all the concepts we are discussing actually. Now we'll discuss about some of the controller objects. So if you look into this scenario here, the pod, whatever I've created, it is up and running in one worker node. And using the external IP address of this node and the node port, I can able to access this application through my web browser. What if this node is down out of 2 worker nodes? If I lost this worker node 1, what will happen? I'll be losing my application, right? Similarly, sometimes your node will be up and running. but the pod might not be responsive. In that case also, you'll be losing your application. So how to ensure high availability? So as per your discussion, like yesterday, we talked about some controller objects. So we can able to create some replicas of your pods and schedule to run in more than one available worker nodes. So that even if one node is down, you have another available node to support application. Or if you lose your pod instance, you can able to use another pod to access the application. And apart from this, there is something called deployment controller object, through which we can able to automatically update or downgrade your application. Right, I'll show you how to do that. There are a lot of deployment strategies involved there. So first, we'll see about replication controller. Listen, please. Both replication controller and replica set. In short, we use a term like RC and RS. Both replication controller and replica sets are used to create replicas of pod. Okay, it is just to create the replicas of pods. That's it. And as per the need, we can able to scale up or scale down. We have kubectl command to scale up or scale down the pod instances. It is possible. And the main purpose of using replication control replica set is it is used to create replicas of pods deploy in the cluster, right? Or you can also consider this as it is used to run the specific pods. That's it. By default, it is used to run a specific number of pods. If you say replicas is 5 means it ensures that 5 replicas of pods up and running. Correct. And another important thing here is there is a difference between your replication control and replica set. So though both these objects are used to replicate or create some replication of your pods, the basic difference is this replication controller uses the based operator and this replica set uses the set based operator. So what is equal to based operator and set based operator means? Yesterday while discussing about your component, right, we discussed about something called labels, right? So labels are used to assign some additional tags to your Kubernetes objects, and it is also used to map that Kubernetes object with any other services, right? So for reference, we can use it. So consider I want to refer one object based upon the environment name. Okay, there are a number of environments like QA, UAT, dev environments, right? So if I use replication controller, I can able to refer the environment using this equal to QA. Similarly, the environment. Okay. So a label can have one possible value. That's it. It is one-to-one mapping. You cannot pass more than one possible value to this particular variable if you're using your replication controller. But the same thing, if I want to achieve it through replica set, I can able to use this set-based operator like this, QA, UAT kind of thing. Correct. So here, the set-based operator means you can able to assign more than one possible value to your environment. So tomorrow, if you want to deploy my application pods in more than one environment, I can able to create some namespaces and distribute my pods in more than one namespace. That is also possible. So in such situations, we can able to use this replica set, and this replica set is based on your replication controller. So going forward, we are not going to use the replication controller. Kubernetes will be stopping the support for this replication controller because it was introduced in the very initial version of Kubernetes. Okay, but the latest version of Kubernetes, we can able to use your replica sets only. Maybe down the line, you won't even read about replication controllers, right? Because replication controllers having very limited capabilities for deploying the simple pods and all. But tomorrow, if you want to deploy your pod using some services or some jobs, right, it is not possible to handle it. Even for deploying your application also here, deployment object. So when you try to create a deployment object, automatically this replica set will get created. Replica sets can be created automatically. Create deployment object, right? So when we create a replica in a deployment control object, automatically replicas will get created. Okay, you don't need to explicitly give any definitions there. See, so these are some basic properties of your replication controller and replica sets. And here also we need to have some manifest file. Okay, so I'll quickly show you the manifest file for creating this replication controller first. So just look into the scenario here. So in my previous example, I was showing you how to prepare the manifest file to deploy a pod. And the pod object is referred. But now we are going to use a term called replication controller. We'll be using API version as V1. And metadata is used to identify the name of the replication controller. And under specification, we are going to give the number of replicas. So replicas means how many instances of pod you want to deploy using this replication controller. That is decided by this replica count here. And what you're going to replicate? It is going to replicate your pod instances, right? Based upon this container specification. So it means in your previous pod definition, what are all things you mentioned in the metadata, like the name of the pod, labels, container specifications. All those things will be defined under a template here. So any controller object you consider, whether it is a replica set or deployment or DaemonSet, will be having a template which defines the properties of the pod that you want to deploy and the container. And here this name and all is optional. Okay, you don't need to give the name for your pod if you're creating through control object. The name can be automatically assigned as per the number of replicas. Once you define your container specification under the template, how this replication controller can identify the template? For that, it uses the label of the template. So there is a concept called labels and selector. So label is used to identify or assign some unique tag to the particular object, and using that particular tag, we can able to select that object using selector key. Going forward, whenever create any deployment object, it is required to define proper label to the template. Name is optional, but label is mandatory. Specify the label name and use that label name in the selector key so that your controller object can able to identify the template. See, so with this, you can create your object. So now, once the file is ready, let's save this file and you can run the same command to create your objects like your Kubernetes object. What command we used? kubectl command, right? You can use the same command. So if you can see here, we have created one object, replication controller object using kubectl command. And if you get the details of your kubectl replication controller, you can see it's RC, it is running 3 desired state because we have defined it with 3 as a replica here. My intention is at any point of time, 3 instances of pod should be up and running. So it has created the pod and the pod name is uniquely assigned by Kubernetes. So that's the reason I told you, while creating any Kubernetes controller object, the pod name is not mandatory. Okay, even if you're not using the pod name also, it will create the pod name based upon that object name. Okay. So kubectl get pods -o wide. So this will get you the list of pods that are up and running along with its IP address and the nodes. So scheduler has already scheduled this deployment. Out of 3 instances of pod, 1 is running in workload 1 and remaining 2 is running in workload 2. So this is how it is distributing your workload. So now my application is available in my cluster. So even if workload 2 is down, I can use workload 1 to access my application. Not only that, using replicas controller, we can able to quickly scale up or scale down. Scale up or scale down. So what is the purpose of scale up or scale down means? Like currently we use a replica as 3, right? At any point of time, I want 3 instances of pod should be up and running. This is my requirement. So if you compare it with the real-time scenarios, okay, in real-time environment, consider I have deployed one microservice. Okay, to deploy this microservice, I need to create some replicas of pods. So on what basis I choose the replicas means there is no standard count like 3 or 5 and nothing like that. It is purely depends upon the usage. In real-time environment, how many users can able to access my application? Say I have created replicas of pods, and assuming that 10 replicas of pods is more than sufficient to support 100 users. 100 users can able to simultaneously access my service. So I need 10 replicas of pods. If I have only 1 replica of pod or 3 replica of pod means it might not support this 100 users. So depends upon the users and depends upon the intensity and the volume of your service, you can able to choose the replicas. During the execution, okay, once the application is live, my assumption is it can be accessed by 100 users, for an example. But all of a sudden, if this 100 becomes 1000, okay, this 100 becomes 1000, do you think the 10 replicas is sufficient to support 1000 users? So here, this particular 10 replicas cannot support 1000 users. So what I'll do means I can able to scale up. So to support 1000 users, I can able to add more replicas, right? Like it can be added with plus 10 replicas I can able to add to the existing one, which can support 1000 users. Like that, depends upon the number of users. In real time, we'll be using some continuous monitoring tools to continuously monitor the network, the traffic, okay, incoming request, everything. Based upon that, we'll define some threshold limit. If the threshold limit of the usage or traffic reaches 80%, we can go ahead and scale up the replicas of pods. So to scale up or scale down the pod replicas using replication controller, we have a command, kubectl scale command. So you can refer to this one. So when I say kubectl scale RC, in replica controller, followed by the name of the controller with replicas is 5. So currently we have just 3 replicas of pod, and now I just want to increase it to 5 or 10. See, instantly it is creating more instances of pods and it's all up and running now. See how quickly we can able to scale up pod instances. And once the traffic goes to normal state, if you want to reduce replicas, you can just reduce it. And all the unwanted pods instance will be deleted and you can have only one pod instance now. You see? So this is a command which I've used here But in real-time scenarios, depends upon the CPU utilization, the memory utilization of that node, and depends upon the network traffic, right? We can able to automatically scale up or scale down, okay, with some matrices. This is about your replication controller, right? And now using replication controller or replica set, we can able to create some number of replicas. Assume that I have deployed this Nginx version, the latest version of Nginx is up and running in my cluster now. Like this, I can able to update more images, right? I can able to create new changes in my source code, prepare a new version of my image. So whenever I go for any new upgrade, if you're using your replication controller replica set, it is not possible to deploy your pods. It might lead to some downtime. So without any downtime, if you want to deploy your pod objects, we can use something called deployment controller object here. Deployable object. I was talking about the replica set, right? So this replica set can be automatically created with the help of your deployment controller object. I'll show you how to create that. Before that, there is one other important topic like DaemonSet. So DaemonSet is also another Kubernetes controller object, and this DaemonSet is used to copy a pod in all the available nodes. Simple as that. So consider I have a cluster with worker node 1, 3, 4, and 5. We have 5 worker nodes in our cluster. If you use your replica set or replication controller, what happens means it is used to run the specific number of pods. That's it. That specific number of pods, it may distribute to other nodes, or if the scheduler assume that this node itself will to run all the functions of pod, everything can be deployed in the same node itself. It is possible. It is not mandated that your replication controller replica set will distribute the load to more than one nodes. If this node is capable to run all the pod instances, it will deploy everything there. But sometimes what happens, we need to deploy our pod in all the available nodes or some set of available nodes. In that case, I can use my DaemonSet. So the real-time scenario is something like, consider I have 5 worker nodes here. And as a Kubernetes administrator, I want to monitor all these 5 worker nodes. I want to capture the logs, all these 5 worker nodes. I want to capture the metrics of all these 5 worker nodes. So the metrics tool or the logging tool, I want to run all the 5 worker nodes in the form of pods. This is one scenario. There is another scenario, like if you want to run any monitoring tool in all the available worker nodes, you can't go and manually run that in all the nodes, or you can install in all the nodes. So what I can do, I can use my DaemonSet and run that monitoring tool or logging tool or a metrics reporting tool through DaemonSet. The main advantage of DaemonSet is it is used to execute a copy of pod in all the available nodes. Another important thing is if you add any node, let's say today I just have 5 worker nodes and I've created DaemonSet. So my pod will be deployed on all the 5 nodes. In future, if you add any number of nodes, automatically that pod will be deployed to that new node. Any new nodes added in cluster, that's it. Similarly, if we delete any node, out of 5 nodes, if one node is getting deleted, or if intentionally delete any node, if any node gets deleted, this DaemonSet automatically for instance. So this is how we maintain the replicas of pod and run in all the available nodes or some set of nodes using DaemonSet. And another main advantage here is consider I have created or I deployed some copies of pod in all the available nodes. Now the point is I won't delete all these pod instances. So I can't manually delete everything. So what I can do is I can even delete DaemonSet, delete all the associated. Right. So you don't need to manually go and delete the pod. Just delete the DaemonSet. Automatically your objects, whatever associated to that set will be deleted. So these are some main advantages of using your DaemonSet. So how you can test this means you can test it using this manifest file. So let me show you one example for this. So consider I want to deploy or I want to create one DaemonSet. So to create a DaemonSet, this is the manifest file. So kind parameter can have the type of that object as DaemonSet. API version for DaemonSet is app/v1. This metadata is used to identify the name of the DaemonSet. Okay. Once you have the name, you can able to give the specification. So in this specification, you cannot give the number of replicas and all because our intention is not to create the replicas of the pod in one node. My requirement is I want to create a copy of pod and deploy it in all the available nodes. So in this case, I'm going to create one template with the label of the template. That's it. The specification, which image you want to use. In this case, you can able to use your Fluentd logger tool or any other monitoring tools like Prometheus, image, anything you can use here. I use this Nginx, so you can use the same. And then, as we discussed in the earlier object itself, this DaemonSet can identify this template by using label of the template in the selector. Matching label is simple. So let me create this file now. So very basic. Okay. Ultimately, we're going to prepare some instance of pod and deploy it in all the available nodes. So save this file. Once the file is ready, you can use your kubectl create command followed by the file name. That's it. So one daemon set has been created, and if you want to get the properties of a daemon set, you can able to execute these commands. Like I have the commands available here. So kubectl get daemon set. Which daemon set you have created, you can able to capture it. See here, in our definition, we never gave anything called replica account, but it is automatically created to as a desired state. Why? Because in my cluster, I have two worker nodes, and this pod instance will get deployed in these two worker nodes. So if I say kubectl get pods, you can see two instances of pods are created based on the daemon set name. This pod ID is automatically generated. The last 5 characters is generated, and it is running in worker node 1 and worker node 2. So that is the main idea. So instead of Nginx image, you can able to maintain your logging tool or reporting tools or any monitoring tools, right? Or sometimes we need to implement some application dependencies can be executed there. Or as an administrator, you can able to do some sort of cleanup activities, right? You can able to run some process, kill some process. All those things can be maintained with the help of these pods. That is about daemon set. So the basic difference between replica set and daemon set is replica set is used to run a specific number of pods. It can be 5 or 10 or 20, but instead is used to run a copy of pod in all the available nodes or in some set of nodes. Easy. So this is about your daemon set and replica set. Replica set, I'll show you how to create replica set using this deployment control object itself. Instead of giving a separate definition, even if you give your definition also, you can see here, right? We are using this replication controller, remember? So this one. In this case, instead of replication controller, you just change it to replica set. That's all. And for replica set, API version is app/v1. As like daemon set, for daemon set also is app/v1. For replica set also will be app/v1. That's it. And all other parameters will be same. Only the type of the object, name, and API version will differ. And I'll show you how it gets created while we use our deployment object. So the next topic in the list is about the deployment controller object. So this is one of the important Kubernetes objects, which is used by the developers to deploy their services in Kubernetes. Like we can able to use something called microservice-based deployment, okay? And it uses some strategies for quickly upgrade or downgrade your pods without any downtime. So this deployment controller object, it is used to deploy a copy of pod, same as like your controller or replica set. This is also used to deploy the pods actually. But thing is that it can able to upgrade or downgrade your applications without any downtime. So that is another important capability here. Okay. So I'll add those pointers first and then we'll have a demo on that. Okay. Yes, you can consider all these pointers to work with deployment controller objects. So deployment controller objects is used to deploy the pods, and it helps to ensure that high availability of pods are maintained at any point of time. And that will be done with the help of replicas. Like as like how you created your replication controller, when you create a deployment object, it creates a replica set through which it can able to create replicas of pods to ensure high availability. And it is used to scale up or scale down. It is a basic property that we already seen with your controller object itself. And in addition to that, it can able to perform the upgrade of application pods, like from one version to another version if you want to upgrade, or if anything goes wrong, if you want to downgrade. All those things can be effectively done with the help of deployment object. And the main advantage is you can able to achieve it without any downtime, right? So to upgrade or downgrade the application pod can be done without any downtime here. And to achieve zero downtime, your deployment control object uses the deployment strategy called rolling update strategy. There are various deployment strategies available, like we have rolling update strategies, canary, blue-green deployments. So out of that, the default deployment strategy used by Kubernetes is rolling update strategy. So before you actually work on this deployment control object, you need to understand what this rolling update strategy means. So consider I have 3 instances of pods deployed, like pod 1, pod 2, and pod 3. And in all these 3 instances of pod, I'm using the application image version 1.0. Okay, so using this application image version 1.0, we have created 3 instances of pods and it's all up and running now. And now I want to upgrade. I made some incremental changes in my program and I want to implement the new changes in production or a target environment. Means from version 1.0, I want to upgrade it to version 2.0, something like this. Okay, so if you have only one instance of pod, assume that you just deployed only one instance of pod, which is running with version 1.0. And if you want to replace it with 2.0, means definitely it will be leading to some downtime, right? You have to down this existing pod and you can able to bring this new changes into that and bring it up. So if you have one instance of pod, definitely it will lead to some downtime. So to overcome that, we have already created 3 replicas of pods. Now, after creating the replicas of pods, how we can able to deploy or how we can able to upgrade our application image. Let's say I have v1.0 as the current version and I want to upgrade it to v2.0. So out of 3 instances of pod, it will take the very first instance of pod and update that image to be 2.0. If that upgrade is successful, then only it will pick up the next instance of pod and update the image. If it is not working, let's say I'm trying to update from v1.0 to v2.0. During this upgrade process, if the deployment fails, due to some application issues or network, whatever it is, this deployment is not successful. What happens to the application? That application will still up and running with the previous version because these two pods are still alive, right? So on end user perspective, if you approach the scenario, end users will not face any issues, correct? So there won't be any issue because it is supporting it through pod 2 and pod 3. The issue is only with pod 1. So we can quickly understand what exactly happened with that upgrade. If it is not working or if it will not work, you can just revert the changes. Otherwise, you can able to proceed with the fix. So whether you want to upgrade or whether you want to downgrade your application, now it means rollback, undo the changes. So in both the cases, there should not be any downtime. That is perfectly actually the perfect Kubernetes. Like this, we have something called blue-green deployments also, right? We have something called canary. Okay, so there are some deployment strategies. Okay, it depends upon your requirement and which strategies chooses for your requirement, you can make use of it. And out of all these things, your rolling update strategy is considered a slower deployment strategy. It takes some time to deploy because it has to update each and every instance one after the other. Definitely, it will take time to complete. But using this approach, we can achieve zero downtime. And while updating any image, if the image updation is successful, then only it will update the next instance of pod. If any one instance is failing, it won't proceed further. You see? So it is not like after moving the changes to all the instances, and if anything goes wrong, we are going to fix that issue. It's not like that. Here, the idea is to prevent the issue. Before it reaches to the higher level of issues, we can quickly prevent it at the very earliest stage. And even you can use your namespace also. Like yesterday, I was talking about the namespace, right? Like kube system namespace, your default namespace, Kubefront namespace and all. Like that, you can able to create your own namespace, like dev namespace, QA, UAT, prod, anything for that matter, and use that as a reference to deploy your pod. I'll talk about it, okay? Tomorrow, once I start with my namespace related concepts, I'll talk about this blueprint deployments with some scenarios. So we'll discuss about all these use cases, okay? Like each and everything is considered as a use case for a deployment control object. First, we'll see how to deploy the replicas of pods using deployment control object, how to scale up, scale down, upgrade, downgrade, and ensure high availability using the zero downtime and all. Here is a manifest file. So as usual, we are going to prepare this file to create a deployment object. So as part of the deployment object, right, we'll be getting three components. One is your deployment component, and next thing is your replica set object, and then pod instances. So these are three objects that gets created with this manifest file. So let's understand the properties of this. So we are going to create a deployment object. So kind is deployment. API version for deployment is app/v1. And metadata is used to identify the name of deployment object and the label. Label for this object is not mandatory now. But tomorrow, if you want to attach this with any of your external services like NodePort Service, in that case, we need to refer this label, right? But for now, this is sufficient. And next thing is about the specification. So our intention is to create some replicas of pods, right? And this will automatically create a replica set. So specify replicas as 3 and enter your container specification under the template. And there's a label for the template. Same, it is same as like what you used for your controller object, this replication controller. And how this deployment object can able to identify the template means by using the selector and the labels actually. So label is used to uniquely identify the template, and that is defined or used in the selector key. See, so let's create this file now. So here I'm going to use image, nginx image of this version, stable hotel version. If you give just nginx means it will install the latest version. But my intention here is I want to demonstrate some upgrade and downgrade. For that, I chose the previous version of nginx. Stable hotel is just previous version, one of the previous versions actually. And nginx runs in port 80, so I can specify it as a container port here. And this entire template can be identified by this label of the template in selector key. Simple, save this file. That's it. So once the file is ready, as usual, you can use a command, kubectl create command to create that file object. See, a new deployment object has been created. And once it is available, you can explore like kubectl get deploy. See, nginx deploy has been created, the first entity. Similarly, if you use kubectl get rs replica set, you can see the replica set got created based upon the name of the deployment object, right? So this is the unique ID generated for the particular replica set. And in addition to that, we can able to explore the pods. See, these are 3 instances of pods created using the replica set 794. Okay, so this is how we deploy our pod instances using our deployment object. And once it is deployed, as usual, you can able to go ahead and explore the properties of the particular object. Like there is a command called kubectl describe command. Kubectl describe followed by that object name. So you can able to understand the name of that particular deployment object, and you can able to understand the labels, selectors, replicas, and you can see the strategy, deployment strategy, rolling upgrade strategy. So whenever you try to go for upgrade, it will update each and every instance of what is it, and it is using the Nginx image stable hotel version or tag, and this is a container ID. Right now, point is we were able to see the replica set deployment pods, and we should know how to understand the properties of the pod. Everything is fine, but when it comes to the upgrade, okay, how we can update the image. So if you look into this scenario here, there is a command called kubectl set image. Kubectl set image followed by the object, Kubernetes object. I want to set the image of this deployment object using this container name and the new value of that thing. So the existing image, whatever we use here, it is stable hotel version, which is up and running now. But I want to upgrade it to stable version. See, for that, what you can do, you can use kubectl set image command. So simply run this command. Before that, let's create this thing here. Kubectl set image deploy nginx deploy followed by the container and the image, new image you want to assign to the container. So if I run this command, it will try to change the image name of that particular deployment object. If you want, I can apply some filter and show you. So currently this deployment object, whatever we have created, it is using the image nginx stable hotel version. Now I want to update it to stable Perl version. That's it. So before you update, ensure that this image and tag is available in your container registry. So let me run this command now. Kubectl set image deploy. It's deployed. Now if I get the image name of that deployment object, you can see it has been changed to PARL, Perl. From stable hotel, it is changed to Perl now. So once it gets updated, my expectation is it should able to get the details of that replica set here. See, earlier this was the replica set ID, which was table 1. Now you can able to see it is having this particular ID, which is just associated to that one. In the meantime, if you get the pod details, see here, the pod, whatever gets created, it is based upon an object and the replica set name. So replica's name is this one, correct? Based upon replica set name, you can see it is created 3 instances of pods here. It's all up and running now. Easy? So hope you're listening, right? 3 instances of pods are deployed in your environment as the initial one. But now, as part of the latest command, I just use a command called kubectl set image deploy followed by that deployment object. Means I just want to assign the new image to my deployment object. It is assigned as Perl now. But when I get the list of pods, you can see there is one pod deployment failed. So there are a lot of chances of getting the error image pull. What is the purpose of image pull means? Error image pull means whenever your CRI is unable to locate that image in the container registry during a deployment, so this error. See, if you want, you can able to get the details of that, like kubectl describe pod followed by the pod name. So my previous instance of pod, you can understand based on which version is installed, it is working. See, it is using the stable hotel. These are the previous versions. Now the latest version, whatever we are going to use here, see what happened? It is trying to update with PARL, but it says error image pull error. So why? Because it clearly says that unable to locate that file. It is not available. Stable-PARL image tag is not available. It is not found. So this is how we can able to do a deployment, and whenever the deployment fails, what we do, it's a failed deployment. I just want to show you during a deployment failure how we can able to address this issue. So in this case, it's clearly visible that the image, whatever we have mentioned in that input file, it is incorrect. So what you can do, you can simply go ahead and update the image. So for the updating image also, we have the same command. Okay, like we can able to simply go ahead and undo the changes first. Kubectl roll undo. So what the command going to means, what all the latest image you assign to that particular pod, it'll get rolled out. The latest change will be rolled out. So like an undo action. Okay. So now let me pull those details first. So this is the image that we are assigned to this deployed object. So what I'm going to do here means I'm going to run this command, kubectl roll command. And now if I get the image details, you can see it went back to previous one. So during this process, we never down the pod. Okay, the pod was up and running as usual. There is no limitations in having the pods up and running. Only the impacted pod. Let's say these 3 pods are already up and running. It is trying to create a new pod based upon the latest version of your application image. If it is successful, then only it will pick up the next instance and keep it in sync. So if the first level itself not successful, then it won't touch these 3 things. That's what happened here. So using this rolling update strategy, we can able to ensure that the applications are active. It is up and running all the time, even during your upgrade or during your downgrade, or if there is any issues during your upgrade or downgrade also, it won't impact your application. See, now how to update this. Okay, so for that, you can simply use your command. Like if you can get the status of deployment, you'll get more information on that. See, it's rolled out successfully. We have changed the image. It is successful. Now, what you're going to do here is we are going to update with the actual image. The actual image name is Nginx stable PERL, not PERL. So I just initially updated this to show you the failure case. Now you have your image ready, so you can simply update your image with this command and immediately check the status of that rollout. So you can able to see how the rollout is getting happen. Like rollout to finish 2 out of 3, 1 out of 3, 1 is getting deleted. So this is what rolling update means. It is not going to update all the three instances of your pods at the same time. It will do it in a sequential manner. That too, if the first occurrence is successful, then it will update the second occurrence. You see? So with this, we were able to update your deployment object with the latest version of your image, and it's all up and running now. If you say get pods, you can able to get these details. So if you want, you can able to get the name of this pod and use the describe command to get those details. See, this instance of pod, it is using stable PR image. Got it? So can you able to experience now how Kubernetes helps to achieve continuous deployment? So without any downtime, you can able to achieve this. All right. So this is all about your deployment controller object when it comes to your upgrade or downgrade. And the next thing is using the same deployment controller object, we can able to scale up or scale down. The command is same, like what we used for your controller object, same command you can use here also. Like kubectl scale command, make it as 10, and you can able to get list of pods. So 10 instances of pods will be quickly created. Or if you want reduce to 1, you can simply say 1 here, controller object. And finally, if you think you don't need all these objects, you can simply use a delete command against the file name. So on this file name, if you use delete command, it will delete the deployment, replica set, as well as the pods, whatever we have created so far. No need to delete the components one by one. Simply use a delete command against the file name. Delete all the associated resources. Easy. So the next important thing is the volumes. Okay, so we'll discuss 2-3 volumes today. And let's say, so as I listed earlier, in my previous session itself, I was talking about some volumes, right? Like these are things. So we'll be learning about the ConfigMaps, secrets, host path volume, persistent volume, and persistent volume claim. So basically, what is image, application image? So whenever we try to containerize the application, we will try to identify all the dependencies, right? So based upon that only, we will first package the application. But once the application is packaged, let's say I have prepared one application image to deploy it in a QA environment. And to deploy my applications QA environment, I need some configuration files. Okay, it is environment specific configuration files are available. So you need to pass that file as an input to your deployment. So instead of passing it as an input, if you hard code those files within an image, means you need to create multiple images for each and every environment. Let's say, consider this scenario. Just take one small example here. Consider I just want to deploy my application image in dev environment. Okay, so in this dev environment, I want to deploy my application image, and to deploy it in a dev environment, I need some dev configuration files to be updated. So if I have the dev configuration file up front, and if I create an application image using this dev file, then you cannot reuse this image in the QA environment. It's not possible. Why? Because that image is already updated to the dev configuration. You cannot pass any QA there. So you need to, it leads to creating a new image altogether with the QA configuration. Simply for each and every environment, we need to have dedicated images. If you have 100 environments, you need to create 100 images. Is that feasible? No. So what we do here is we will prepare this image as a separate entity. We never include any configuration file during the image creation process. So all that we do here is we are just going to prepare one application image, and what are all the inputs required? What are the input files required to deploy this particular image in Kubernetes? That will be passed at runtime like this. Through your manifest file, you can pass it. So now when it gets deployed to dev environment, it uses this file as an input and deploys it. So how it is possible means in Kubernetes, we have a concept called ConfigMap. So ConfigMap is used to maintain some data, okay, for your pod deployments, and it will be maintained like any generic data you can able to maintain with this ConfigMap. So this ConfigMap volume is used to pass the configuration as an input. That's it. So what are all the files you want to pass it as the input? It can be to any target environment, QA, UAT, or production, whatever it is. So what type of image or what type of input file you're going to pass along with that image or at runtime? That will be decided by this ConfigMap. And this ConfigMap are used to pass or share the sensitive data files. So if you use any ConfigMap volume, the data whatever you maintain in the file, it can be exposed even outside the pod. Okay, it will be available. It can be exposed. But if you, instead of passing some config map or configuration data, if I want to pass some database credentials, let's say I have deployed one application database, I just want to manage my database, right? So for that, I need some database credentials. So you cannot pass any sensitive data with the config map. For that, we go with a concept called secret volume, encrypted. So whenever we try to handle the data or any input file using secret, it will just encrypt data. It means the data is accessible only within the pod. So it is used to share the sensitive data files, and this particular thing, okay, that matters. But this used to access the file content even outside the pod. Okay, so that makes difference. So how to prepare this config map and how to prepare the secret? What is the default template to create the volumes? Means it's very straightforward. It's just going to use our manifest file, and I'll show you how it looks like now. 1 minute. Okay, so if you can see this example here, this is an example for your config map, and there's another example for secrets. Okay, so it is very difficult to maintain the secrets, but it's not that required to maintain it here. So all that we're going to do here is first we'll see how to set up this in our environment. So I'm going to first create the config map. And as I said already, config map is used to maintain some files or data here, right? Used to pass some config file as an input. So how we can able to get this config file? How this config file can be captured, from where it can be captured? So this is the configuration file, okay, to set up your config map, secrets and everything. So as I said already, the config maps are used to maintain some data that can be exposed. Okay, it is not any sensitive data, can be used in your config map. So just look at the scenario here. I'm going to prepare this config map. This is a command to create config map. Kubectl create config map command, followed by the name of the config map. Correct. And here, this config map requires some input files, right? That is a basic property here. Files are required. So how to pass this file means, like you can create your file on the same machine itself. Okay. F1 text file and F2 text file. So it means the file is safe now. Using this file, you can able to create the object here, ConfigMap objects or whatever, and then use this get command to understand the properties of that object. That's it. So now, once you have the ConfigMap created, you can see kubectl create ConfigMap followed by the name of the config map using this from instruction for file 1, and this is for file 2. Using these two files, we can able to create one config map volume. Syntax is same. And then you can able to verify the results, like where it gets installed, what is the IP address, everything can be described from here. Once this is done, the next thing is how you're going to consume that volume in your pod. Further, what you can do, we can again go with your pod deployment. Okay, like during your pod deployment, what are things you use? You can use the same thing. Like I'm going to use a pod type, and the metadata is going to identify the name of that particular object, pod object, and the specification is going to identify the name of the containers, image name, two more parameters. One is volumes, and another thing is containers. Volumes and containers. So volumes means it is something which can be mounted to your container. So just look into the scenario here. Till this, it is common. You must be aware of it. Already we did it. But now the special cases, in order to deploy this particular pod, I'm going to attach my config map volume here. So to attach any volume to your Kubernetes object, use the volumes key, give the name with the relevant, and then enter the type of the volume that you want to use. So config map is a type of volume, right? And once it is configured, using this DNS or your web URL, you can able to access that application. It's not an issue. Fine. So now I have prepared this config map. This is the name of the config map volume, and I just want to attach to my pod. So usually in your Docker module, when we were discussing about the port mapping and volume concepts, we were discussing about that, right? So how we can able to map our container volume with your host volume. What is the command for that? If you remember, first we have prepared the Docker volume. We have created a volume, and using that volume, we can assign it to the container volume, right? The host volume will be mapped to the container volume by using using the external volume parameter. Similarly here, by default, the container will be having its own mount path. So in that mount path, you're going to add one new file, and then that will be mapped with the actual volume that is available outside. So the config map, whatever we prepared, it is applicable at the cluster level, not within a node, right? Sorry, it is applicable at the cluster level. But point is, the data, whatever you maintain in secret volume, it will be encrypted. Okay, and only the encrypted data will be maintained in your thing here. So let's get into this now. So this is the volume which we have prepared. at the cluster level, the ConfigMap volume, and this is just a name of the volume, this tag we are assigning to that one. Once it is done, you are going to use this volume mounts, identify the directory where you have that component available, and then make it as read only true. So it means any user who wants to work on Kubernetes using kubectl commands, we can able to limit the access. Okay, only some number of users can use this command to update this file. I cannot give update access to all the users, right? So like that you can able to control the access levels. See? Similarly, if you compare it to the secret volume, so there's an example for secret volume. I have two files. One is admin and password file. Based upon that admin and username and the password field, I'm going to prepare one secret volume. Kubectl create secret followed by the file names, whatever we want to attach to that particular date. That is the basic difference between config and secret. Point here is the config map and secrets are available, and you cannot directly read the content of the secret volume. It will be in an encrypted form. Correct. But your config are not like that. Okay, let's create these two files first. So I'm preparing two files, file 1 and file 2. And I just want to attach this file to another container or pod. It can be in the same region or different region, also no problem. So now we can run the command kubectl create command to prepare this config file along with the volumes. It's created now. Once it is created, you can able to use the get command to get the details and describe the properties of the config map. See, I get your point. So they have just taken it to the next level and it is still exist here. Okay. So when I say describe command, kubectl describe followed by the config file name, in the case, you can able to see the properties of the particular config map, right? And in addition to that, you can something called data, the files, whatever we have, like your file1.txt and file.txt, it's all associated in the same definition of pod deployment, but it will be utilized only during runtime. You see, in the same way, if I try to execute any sensitive data like secret, password, let's create these two files, and based upon these two files, I'm going to prepare one secret volume. Secret also is created now. So once it is done, you can able to get the details of the secret volume. Like kubectl get secrets command will get you the secrets whatever we have prepared in this infrastructure. As of now, there is only one secret value available. And the next thing is you can able to use a describe command here. So in config map and secret volume, what is the difference actually? So as like the config map for secret volume also, I prepared two files and I just pass those files to secret volume. But when you say describe command, the describe command can able to get you the complete properties of that object. And here it is showing me the file name along with the record. Which record is available file, it is getting exposed now. Same data, if you maintain using your secret volume, you can see you can able to find the file name, but the actual data will be encrypted. It's saying like 9 bytes and 5 bytes. You cannot see the content of the file when you create it through your secret and access data through, outside that particular volume. So that is about your config map and secret volume, and you can able to attach it through this command itself. Like while creating the pod, you can attach that volume to that particular pod. See, so the next thing is about the persistent volume. So this persistent volume is same as like Docker volume. So in which node you are deploying your application, on that node, you should be able to prepare the volume. Correct. That is what the host path volume means. Okay, so during the deployment only, they'll be creating that file, it seems. So I'll show you how to work on it. Let me get into this file. Okay, so just look into the scenario here. There's an example for your host path volume. So let's create one file here. So there's just a process of creating a volume. Okay, like what I said about the volumes here. So when we talk about the host volume, it's same as like a Docker volume, but the only difference is it gets allocated at the cluster level. In which node your pod is getting deployed, exactly on that node, your volume will be created. Okay, let's create this one. And here the volume key is used to identify the host path volume type. And this is the directory we have in our machine. Similarly, your volume mounts, that is going to identify the directory on your target and the name of the volume. Name, it can be anything, but use a name to refer it in your volume. Not only this path will be assigned to this mount point. Save the file, kubectl create. So this is a command we can able to quickly use to create this object. We create this one. So now the host path volume is created. So if I say kubectl get pods, see here, it looks really good actually. So here Nginx host path, which is having these references, right? So all that you can do here is we are going to delete some process that is outdated. We really need 5 instances of your thing here or 2 instances of your DaemonSet. So if you want, you can delete it or you can add more CPUs. Just go to your organization, AWS settings and update that change with the latest one. And the main advantage of using this, let's say, let me use this parameter, -o, white parameter. Okay, so this is running in worker node 2. So let's get into this volume, just a node, okay, because it is running in worker node 2, right? So I can go to that instance. Okay, so now if you can see here, we have logged into our worker node 2. we just log into a worknode 2 now. And once you log into this, you can able to see the test viewer folder has been created here. As of now, this folder is empty. There is no changes, incremental changes happen at this point of time. So it is empty. So assume that I have deployed my application in this particular pod and I just want to update the volume for the particular pod. Might be relevant to that, or it can be any other third party. So I'm going to prepare one data here. Okay, so I'm on this worknode 2 and here I'm going to create one file like file1.txt. So once you have this file ready, it's created in your host machine, right? We just created this in our host machine. And once it is available for access, the data, whatever we prepared in that directory, it is available, right? And the same can be used in your containers. I mean, what do you call this? Pods also. Okay. So maybe it is something you can directly compare it with the Docker volume, like how you created Docker volume and mounted to the container, it will be in sync, right? Whatever changes you make in the repo in that particular container, it will reflect in the other end as well. Similarly, here also, whatever changes you're making in that particular volume on your node level, if you log into that particular container, you can able to understand it. I mean the pod. So let's log into this one. kubectl get pods. Yeah. So this is a host path volume I prepared. It is up and running. So I can log into this one. So kubectl exec -it followed by the file name. Okay, using bash. See, we just log into this, and if I say ls, I should be able to see the files present in this files and folders present in this root directory. And here, if you observe, there is something called test mnt folders created now. So we are inside the pod, and in that pod file system, we can see test mnt. If you get to the test mnt folder, you can see the file name, a phone or text file. This file was created in your host machine. Remember? So whenever you attach that volume with your pod definition or deployment, the data, whatever you maintain, it will get updated to this also. So this is how we can pass the input to your container volume. Similarly, your container also can produce some data, right? It can be in the form of reports or logs, whatever. So let's say I'll create one file here. Can you see this? I have prepared this file. File a.txt is something I have prepared. So it means the image, whatever we use, through that we have built that, and then we can able to handle this also within the mount point. Same thing, if you in the meantime, if you go to your system and if you say ls, you can get that file here. So always your VM volume and the container volume will be in sync. Then only you can able to handle this data, correct? Easy. So how to validate this means first create this host path volume, log into your host machine. That is, here it is node 2, and explore that directory. Like test viewer is created or not, you can explore it. And you can always keep that in sync with your actual directory. Why it is called as host path? Why it is called as a host path volume means the volume will be created exactly in the host machine where the pod gets deployed. If it is deployed in a worker 5 means in that worknode 5 alone, it creates the volume. Easy. That's it. In the next session, we'll be discussing about other interesting features related to volumes. Like we have another core concept like persistent volumes, persistent volume claim, Kubernetes services. You can have Kubernetes services also there. Like already we talked about NodePort service. I'll be explaining you that in detail. And once it is done, we'll be discussing about cluster IP as well as load balancer. Okay. And then we'll get into Helm charts.